Okay, so I'm here. I'd like to introduce the speakers for tonight. The first speaker will be Tina Neal. Tina is the scientist in charge of the Hawaiian Volcano Observatory. Also here is Don Swanson, research geologist at the Hawaiian Volcano Observatory, and Kyle Anderson, who was at the Hawaiian Volcano Observatory, is now at the California Volcano Observatory, but has come back to lend us a hand. He's a geophysicist. So Tina Neal, Don Swanson, and Kyle Anderson are here to give you information. Thank you for coming out tonight.
Thank you, Janet. Good evening, everyone. Thank you all for coming, and thank you to the National Park Service for hosting this event for the community. I'm sorry that some people had to be turned away, but as Janet said, this program will be rebroadcast, so please spread the word to others who wanted to be here but couldn't get in. Don and Kyle will be giving you more of the details of what is happening now and what might be coming. I would like to first of all say that the most important message that I'd like to start with is that what we're looking at in the change of activity at Kilauea right now is something that you should not view immediately as life-threatening. What we're going to be talking about is the impact of ash explosions at the summit, potential ash explosions that may be coming. And ash fall is a nuisance. It definitely can have impact on things, on people, on infrastructure, but it is not life-threatening. And we'll end with some resources to point you towards to help you prepare for the possibility of ash fall. I also want to acknowledge that in the audience we have members of the HVO staff who are part of the volcano community, including myself. In the back we have Asta Miklius. Please raise your hand. Kevin Kamabayashi, another volcano resident, and is there someone else out there that I'm not seeing? Leslie Gordon from USGS Menlo Park, and I thought I saw Ingrid Johansson. Let me assure you as well, HVO is working very hard to track this situation and provide information 24/7 to the authorities, to the Park Service, to help them make the right decisions about protecting public safety. I acknowledge that this is a very uncertain and anxious time, and I hope the information that we present for you tonight and the questions that we're able to answer will give you some comfort that you can take control of the situation. So first up is Don Swanson, who I think many of you have heard many times. He is, excuse me, he is the expert on the processes unfolding here at Kilauea, and I think we'll learn a lot again from Don.
Thank you, Tina. Yeah, I've been up here on the podium many times, but this is the most challenging because we're trying to anticipate excuse me, what is going to happen rather than what has happened, which I usually talk about. What is happening is shown in contrast. On the screen you see what was happening on April 25th when Halima'uma'u was overflowing onto the crater floor. And yesterday morning I took this photograph looking down, down, down into the lava lake, which has receded something like 920 feet or so in that time. This is striking. It's unprecedented since 1924 at least. In 1924, there was a series of explosive eruptions that I'll be talking a bit about in a while that we think it might be a pretty good analogy to what may transpire here. But before I get into that, I'd like to have Kyle come up here and describe the next slide that he has put together that is really amazing. Kyle?
Thanks, Don. So Donna showed really nicely what the lava lake looked like on April 25th and what it looks like more or less now. I think the question is then, how did we get from that point to now? How did we get from point A to point B? And maybe even more importantly, and I know what's on all of your minds, is what happens next. So this figure shows a time series of the height of Kilauea's lava lake. So the x-axis, the axis on the bottom here, shows time. So this goes from April 29th all the way up to May 13th. The vertical axis shows elevation of the lava lake above sea level. Now I know that's not very intuitive for many of you. This is also in meters. Just to put this in context, you all remember when the lava lake was overflowing quite recently. So at the end of April it was overflowing. That's up here. That's a little over 1,000 meters above sea level. That's the height of the crater floor in Halemamau. So what happened? Lava lake was really high. It was overflowing. It actually went up a little bit. Right around here is when Pu'u'o collapsed. So the summit did not actually respond apparently very rapidly when that happened, but over a manner of a couple of days, you can see that the lava lake started to drop, and it started to drop at a gradually increasing rate. The black dot here now is the time of that magnitude 6.9 earthquake. Since that time, you can see that the lava lake has dropped in a very, very steady manner, in fact, a remarkably steady manner. The rate of the drop of the surface of the lava lake is about 2.2 meters per hour. That's about 170 feet per day. So it's really quite striking how linear this is, and that's actually surprised many of us, maybe most of us, at the observatory. You may notice here that the data is very thick up here. There's a lot of data points, and more recently, I should say we're right about down here, and this is our most recent data point, circled by the little green dot right there. We don't have a lot of data points recently, and that's because as the lava lake recedes, it gets harder to measure. We measure this with laser rangefinders, and they don't work very well when the lake is very deep and the crater is filled with a lot of plume. We do have other ways to measure it. I think best case scenario, we'll probably get a measurement maybe once per day in the sort of short-term future. So the figure on the left here shows how much we've dropped so far. That's about 930 feet. It's a pretty substantial amount. And you saw that in Don's photograph. So the obvious question then is what happens now? And the answer to that, first of all, is we don't know. I really want to emphasize that. We're in uncharted territory here. We can make some simple extrapolations. Actually, let me go into a little more detail about why we don't know. So the lava lake is dropping because magma is draining out of the summit. So it's draining out of the lava lake through the summit storage system and somewhere down probably into the east drift zone. Now, Kilauea has undergone a lot of changes over the last few days. We've had a big earthquake, we've got an eruption in the lower east drift zone, and we've had a lot of magma potentially leaving the middle east drift zone. So a lot of things have happened. Whatever is driving this, the magma is leaving the summit, and it's doing so at a pretty constant rate. The thing is, we don't know exactly where the magma is going. It may be going somewhere into storage space created by that large earthquake, or it may be going into the Middle East Drift. What we know for sure is that it's leaving the summit at this constant rate. Since we don't know exactly what's driving this process, we can't say when it might change. The system could change tomorrow, or it may not. The best we can do right now is say, if the system continues on its current path, that is, if it continues to do what it's done for the last 4 to 5 days, then we can really just draw a line through these points. And we can say that sometime around the middle of May, potentially, the surface of that lava lake will reach a height of about 600 meters above sea level. And that's important because we think that's more or less where the water table is around the vent at Kilauea. And I'm going to let Don tell you a little more about why that's actually important from a hazards point of view.
The water table. Why is the water table important? Well, I'm going to show some diagrams now that I've shown in a previous After Dark talk, and so I apologize if it's repeating, but I think it illustrates what we think is the process that is leading to the explosions that may or may not occur. We start here with this diagram showing the presence of a lava lake in red and the conduit that is carrying magma up from deeper in the earth from the summit magma reservoir that is feeding that lake. In the diagram, the water table is shown by the horizontal line and labeled, and the diagonal lines, which you'll see in all the diagrams, are simply the wall rock to the conduit. So this is the way that the lava lake has been for much of the last 8 years or so. Now we get to the next stage, which is the stage that we're in now, well, not quite now, but almost, where the lava lake has drained, go back here, has drained out of the crater down the conduit to a depth below the water table. Now, why is that important? Well, when the conduit is full with magma, as in this first diagram, groundwater can't get into the system. The magma is too hot, it's completely filling the conduit, and it's keeping the groundwater out of the conduit. So there's no important mixing between the lava and the water. However, when the conduit is emptied of magma, then groundwater can move in to the conduit. I should point out that the water table is the level below which rocks are saturated with water. So if you punch a hole through the water table, water will come in and fill that hole. So that is what's happening here in this diagram. The conduit has emptied of lava, and groundwater is starting to move into the conduit from both sides. Now, in the next diagram, we see what happens when the water moves into the conduit. It's heated up. When the magma leaves the conduit during the draining process, the conduit walls are still red hot. And so when groundwater moves into the conduit, it is heated instantly to steam. And in this diagram here, the steam is simply rising out of the conduit and forming a nice big steam plume up in the air, and everything is fine. This is not a hazardous situation. However, the walls of the conduit are in general very unstable, and indeed they are present. This morning I was down there and we saw lots of big rock falls taking place. Rock falls can peel off of the walls of the conduit, crash down onto or into the empty conduit and form a pressure seal up the conduit so that steam that is being generated below the seal can't escape passively. So it builds up pressure. And all of you know that that's a bad situation to be in for steam. And eventually what happens is that the steam pressure overcomes the weight of the rockfall dam, and you get an explosion. The material that's exploded out is probably mainly the material that cascaded into the conduit from the conduit walls. It can be thrown upwards of 20,000 feet in the air, the finer particles of it. And these explosions, judging from the 1924 series of events, the explosions can last a minute or two or three, something like that, and then they die out quickly. Now, what was observed a couple of times in 1924 is what you would sort of intuitively expect, and that is that if you're observing the steam plume that is rising passively up the conduit, and then it suddenly shuts off, so you don't see any more steam, that might be an indicator that there's been a rockfall that is trapping the steam below it. And so in an ideal situation, you may be able to anticipate an explosion if you see a sudden drop-off in the amount of steam coming out of the volcano. Now, that was not observed very often in 1924, and I think it's a problem of reporting, and also people sort of lose interest in just steam coming out of the volcano. But in any case, that has been seen. And so these explosions then last for just a short time, and then the conduit becomes clear. Water is still pouring in, forming steam, and we resume the steam emission phase just as we had up here. In 1924, there were 2.5 weeks of such events. I think more than 60 of the events, some of them kind of hard to define. They would take place usually several hours apart, though there were exceptions. And if I had to guess, that is what I would guess is going to happen next at Kilauea if the magma drops down to below the water table. Now, these explosions produce deposits of ejected material on the ground surface. And the next three slides, the final ones that I'm going to be showing, illustrate the distribution of material deposited from the explosions, starting with the coarsest material and ending up with the finest material. It is the finest material, the ash, which will almost certainly be of most concern to you, but I want to go through the two larger stages as well. So the first stage is one that produces ballistic ejecta. Ballistics are rocks that are ejected like cannonballs or like a baseball off a bat. And they fell around Halemaumau. Now this is a complicated slide, and I'm not going to get into detail, but this is the rim of the Halemaumau before the explosions occurred. The crater widened, so this is the current width now, and all the dots are ballistic blocks, the sizes of which I have measured. They get up to the size of about 10 tons or so, maybe 2 yards in diameter. But they're confined, as you can see, to near Halemaumau. This is the scale down here, so the length of the bar is only 0.6 of a mile. So these ballistics were not thrown out more than half a mile or a little bit more than that. So it's unlikely that they would impact the caldera rim at all. The next size of ejecta, however, could. This involves material that would be softball size and smaller. The lines show the extent of rocks of a given diameter. For example, this line here shows the farthest out that rocks that were 0.4 of an inch in diameter extended. In the middle here, excluding the ballistic blocks, they get up to several inches or so. Of interest to you, even though most of these were confined to within the caldera, is that up here at the volcano house, the old location of the volcano house, pebbles the size of about 1/10 of an inch fell. These would sting, certainly, and they would scare you. They probably wouldn't be lethal, but you wouldn't want to experience that kind of a fall. But now we get into the more important material that is ejected from the standpoint of hazards to you, and that would be the fine ash. I don't have a map showing the absolute distribution of the fine ash because it was never prepared in 1924, and rainwater quickly removed it. But from comments that were made at the time, we know that ash fell in North Hilo up at Hakalau, all the way down into Lower Puna. It made the railroad tracks in Maku'u so slippery once that the engine couldn't pull the train and had to stop. Ash coated all this area here, down to Pahala and as far as Waiohinu. The ash covered that much of the area, despite the fact that the winds were trade winds most of the time. And so that's surprising, and what that is suggesting is that some of the columns of ash reached up into the jet stream, which could blow the material in a counter trade wind direction. So that would mean column heights of at least 20,000 feet, or maybe a little bit more than that or so. So that's the kind of material that you can expect to be exploded out of the volcano if we get into one of these phases. And I'd like to turn it back to Tina now, who can talk to you about how to find out more about the hazards produced by the ash.
Thanks, Don. So again, we think it's most important to focus on the potential impacts of volcanic ash fall. And to help you with that, there is a great resource on the web, and I'm working with several agencies to try to get some reprints of the booklets and posters that go with the information on the web. The URL is up there at the top, and you don't have to write it down because there's some handouts in the lobby that have this website on it. But if you can go there, you'll find information that describes what volcanic ash is, its impacts on a variety of elements of our lives, everything from health to power, transportation, water supply, equipment and communications, with very specific information about the impacts and what you can do to mitigate those impacts. So I encourage you to take a look at it, and there are some really well-done booklets and pamphlets that can be downloaded, and we will try to make some hard copies of those available as soon as we can. I think the main thing to know again about ash is what I said at the beginning, is that it is not in itself a life-threatening phenomenon. It's an irritant, it's a nuisance, especially if it goes on for many weeks. There is information here about what to do with regard to protecting your property and your pets, and including your health. Guidance on what type of masks might be the most useful if you have to be outside in an ash fall. Generally speaking, it's prudent to avoid exposure during an ash fall if you can, but again, it's not life-threatening to be in a fine ash fall. I've been in many of them in Alaska, and what I recall being the most difficult part is keeping it out of your eyes. So wearing goggles if you have to be out, being particularly careful if you wear contacts, because if the ash gets behind the contacts, it can actually scratch your eye. Those kinds of tips and hints are all available on these websites. I think at that point we should stop, and because I'm sure you have a lot of questions, and we'll bring Kyle and Don back up here to answer your questions. Thank you. Yes, sir.
Wasn't there a lake deflation in about 2011 and it just didn't go down as far? Is that what the situation was?
Yeah, so the question is, wasn't there a deflation of the lake in 2011, and did it not just go down as far at that time? And yes, that's right. So there was an eruption, we call it the Kilauea eruption at that time. So there was an intrusion of magma in the rift zone, and that caused the deflation of the summit, and the lava lake dropped substantially at that time. It did not drop as far as what we see now, and what's I think maybe more important is that the rate of the lava drop during that event was initially rapid, but it gradually, in fact, just over the span of a few days, it slowed gradually. We're not seeing that this time. What we're seeing is that the rate is really very constant, so this is quite different than what we saw during Kilauea in 2011.
Yes, thank you for your presentation. One question I'm sure that a lot of people are probably thinking about is, I know that we've all heard in the past of cases of much more dramatic eruptions that would cause more widespread destruction. So are you saying that this episode is a different category of thing, or is that entirely ruled out?
Yeah, we are saying that the question is that there have been larger explosions in the past. In fact, I've talked about them many times here. Why are we not discussing them now? Is what's going on now different? And the answer is yes, at this stage at least, what is happening is different. We are seeing a very localized withdrawal of magma. We think that before we get into a stage in which the very large explosions take place, they will have to pass through this stage of smaller explosions due to the withdrawal of the magma. And so there's just nothing to suggest that we're jumping ahead into a large event. Let me give you an example. Currently, the caldera floor of Kilauea has dropped because of the deflation, a few tens of centimeters or so, a foot, let's say, on that range. In 1924, the caldera floor dropped more than 13 feet. And even that did not trigger a period of large explosions. And so I think that we really need to focus on the possibility of the smaller explosions and see how things develop before we start to be thinking more about the big powerful explosions, which could be much more hazardous.
Over here.
What is the composition of the ballistic material?
The question is, what is the composition of the ballistic material? I assume you mean the chemical composition?
Well, you know, that
The
matches it. You know, a baseball-sized piece of basalt would have a dramatically different effect than a baseball-sized piece of pumice.
The question is whether where the ballistic blocks are really heavy and not pumice, and yes, they are heavy. In fact, they represent wall rock from the conduit that has fallen in and then is blasted out. And many of them are actually denser than a piece of pahoehoe, say, that you go out now and collect, because the vesicles, the bubbles in these wall rocks have been filled in, and other changes have taken place. So these rocks can be very, very heavy. And so when I say that blocks can weigh 10 or 12 tons and be ejected half a mile or so, these are not so big, but they're just heavy because they're very dense.
If I could just add, in contrast to that, after this morning's event, which maybe some of you saw just around, I think it was 8:30 or so, Don went down to the crater rim to see what had been thrown out of the conduit this morning, and instead of the heavy, dense basalt that he was just describing, what he found was a lighter weight, more pumiceous rock that was bits of the lava lake that had been exploded up from depth. So we went down this morning, or he went down this morning to test whether we were actually bringing up dense lithic blocks. Yes, in the back.
Yes, the day of and subsequent to the 6.9, down at Volcano Village and where we live at the end of Jade, there were a number of magnitude 3 to 3.5, very shallow depth. Can you offer your thoughts on the mechanics of those quakes?
The question regards the number of very shallow and felt earthquakes around the time of the magnitude 6.9 on the south flank of Kilauea. Those were indeed rather unusual in an area that we do not normally see earthquakes. And I'd have to say that I don't think there's consensus yet on what they really mean. However, a 6.9 earthquake is certainly large enough that there will be aftershocks throughout the region that slipped during the earthquake. And that is one reason in the subsequent days there were many events scattered throughout the south flank of Kilauea. And we can expect aftershocks to continue for weeks to months more. Do either of you want to say more about that scattering of earthquakes? Okay. Sorry to put you on the spot. Tom.
Yeah, just to follow up on Don's comment. Don, could you elaborate why you think Kilauea will pass through a series of small explosive eruptions before it gets to one of these periods of 1790 type explosive eruptions that involve much more destructive capabilities?
The question is why I think that we'll have to pass through a Halima'uma'u draining kind of series of events before we get into a big one. I think small ones presage big ones, and there's a lot of evidence that the lava lake is draining, that it's approaching the water table, and we can make reasonable hypotheses that will generate explosions. There is no evidence now whatsoever that we're in a situation where we're going to have wholesale caldera collapse, or even the collapse of, say, the Halima'uma'u magma reservoir independent of the lava lake. So I think we have to wait for evidence before we start worrying about the biggest, most hazardous events. I'm not saying that they're not going to happen, but they're not certainly in the foreseeable future, and we see no evidence for them.
Thank you.
Do we have any kind of, will we have any kind of notice between the time that enough rocks fall to block the steam plume to the time that that causes an explosive eruption?
The question was whether we'll have some time or warning of a steam explosion that produces the deposits that Don described. The answer is probably not. These phreatic, or is another word or for steam-driven explosions, tend to happen suddenly. As Don described, there may be this process of a visible steam plume that disappears during the time of pressure capping and pressurization. But at night or during bad weather, Kilauea is only a mile outside my office, and there are many days I can't see it. That visual clue may not be there. So we do not think that we will, at this time, see recognizable geophysical precursors to such a thing. That could change. One of our jobs is to look for patterns that we can recognize repeatedly, and if we are witness to some of these events, we might develop some insight. But even then, we think the warning would be so short, it would really not be of much use. Yes, ma'am?
So are these explosions predicted or potentially could cause large tsunami events, and would camping on a beach over the next few weeks be a bad idea?
You have a field camp coming up. The question was whether this activity could at all produce tsunamis or be associated with tsunami. The answer is no. The impulsive, explosive events we're talking about are up here at Haleit-Maumau. They shouldn't have any effect on the coast. With that said, we are still in a period of significant potential aftershocks. So there is the possibility of certainly a large felt earthquake. Yeah. Yes, ma'am.
Ash might go on for 2 months?
In 1924, this explosive activity that we described went on, I think, for 2 weeks, two and a half weeks. But frankly, there's no reason to believe or assert that it will be an exact replay of that duration in 1924. But I think the bottom line is once this process starts, we should be thinking that we might have to deal with it for weeks.
Is the ash hot?
Is the ash hot? Don, you want to hit that one?
The question is the ash hot? And it would be hot or very warm immediately upon eruption, but it cools quickly when it gets in the air. And so it will be cool when it lands. And in fact, much of the ash will probably be wet when it lands. Because the steam that is driving the explosions, the steam will get in the air, cool, and condense. And so the ash that rains out will be wet. And that presents a problem, actually, at times, because wet ash will cake onto things, whereas dry ash would just fall particle by particle and slough off. So, but anyway, to answer your question, the ash will not be hot when it lands.
I should also point out that ash that is wet is much heavier than dry ash. And one of the concerns if the ash accumulation gets to a certain point is the weight issue. There were stories of the 1924 ash, I think, damaging gutters in Glenwood because of it washed into the gutters and was too heavy. So at certain accumulations, the weight, especially of wet ash, becomes an issue. Yes, sir?
Yeah, I assume the volume of material that's dropping out of the lake and the conduit vastly exceeds what is coming out of Lower Puna right now. Where's that material going, and what would you speculate might happen?
So the question was about the volume of material that's leaving the lava lake now and comparing that to the volume that's coming out in Puna right now. That's actually a great question. The volume that's coming down out of the lava lake, we have a reasonably good constraint on. We know something about the geometry, especially now that the lake is drained. We can go out and actually measure how big the conduit is. Those measurements are still underway. I think we have a ballpark estimate. It's probably on the order of a few million cubic meters. Those are just some back-of-the-envelope calculations I did earlier. As for Lower Puna, I'll ask Tina about this, but I believe that we actually have not a fantastic constraint on what's coming out. The volume has not been huge. There have been a lot of small fissures, not a lot in the way of large lava flows. I don't think we have yet a lot of quantitative numbers on how much has actually come out of the ground, unless Tina has an update on that.
No, I don't have an exact number yet, but it's certainly not any more than a couple million cubic meters. In fact, I think it's much less than that. The fissure vents and the lava flows have been really small volume. So there's not necessarily one-to-one correspondence between the volume we've lost here and what's come out down in the fissure vents. Yeah. Yes, sir?
Would there be sulfuric acid mixed with the wet ash?
Yeah.
And also if you could comment on the acid rain that has been in the news.
Sure. Comment on acid rain and sulfuric acid, the sulfur dioxide gas that might be part of these explosions. We would expect each of these explosions to produce a burp of sulfur dioxide gas as well. When that mixes with the water in the atmosphere, it can produce acid rain. But I'll remind the volcano community, you've been dealing with that for 10 years now, so you have practice. And I don't think we would expect the conditions with regard to acid rain to be any worse in this type of activity than you have experienced already. In the same vein, the kind of particulate infiltration into your water systems, you've also been dealing with to some degree with the Pele's hair and other fine, in cases, fine pieces of volcanic glass that have been lofted into the atmosphere during the lava lake period. Yes, ma'am.
For those of us who have livestock, is it something that we should start thinking about moving them out, or just covering them within our own property should be sufficient based on the amount of ash that we should expect?
The question was about if you own livestock and if you should be thinking of moving them out or just protecting them. My guidance, and I would encourage you to look at this website for further information, is that protecting, making sure that they have shelter and can be sheltered during ashfall events is probably the best approach. One thing to think about is that this kind of volcanic ash, if it falls on the feed area for livestock, may not be good for them to eat.
Right.
Yeah. Yes, ma'am. Oh, Anne-Marie.
Yeah. What kind of say, daily accumulations of ash might you expect? Do you have any idea?
Don, you answered that question at 4. I'm going to let you go there again.
The question was what kind or how much daily accumulation of ash can you expect? It's hard to say, but I would say a small fraction of an inch normally out where you live, and probably mainly when Kona winds are blowing. The ash will fall out of the air after each eruption over a course of a few tens of minutes or so the air will probably clear between explosions unless the explosions are very close together. I wish we had more information about the ash, though, but as I said, in 1924, they really didn't pay much attention to the ash. They had a lot of other things to do. And as a result, I can't be really specific about what you might expect in volcano, but I think it would be a small fraction of an inch.
Okay, in the back.
One of the volcano websites on Facebook recommends we start bringing our pets in as of Friday. Can you comment on that, please?
Well, the question was about whether we should start bringing our pets in as of Friday. You may recall Kyle, in his presentation, pointed out that intersection of the projected line of descent of the lava column and time looks to be Friday. But that's no absolute guarantee that an ash-producing event or events will begin to happen on Friday. I think it's best to wait to see what happens and bring your pets in accordingly. If we have strong trade winds, volcano should be largely protected from volcanic ash fall unless it goes extremely high and we get wind reversal as Don described. Yes, ma'am.
Well, I have a question, and maybe it's just that I don't completely understand, but when you're saying the word explosions, and I understand we're kind of in store for aftershocks and things, but do explosions generate kinds of quakes, earthquakes again, in bigger numbers?
The kinds of explosive process we're talking about here would not be something that would create an earthquake similar to the ones you've been feeling in the past few days. However, there can be, in fact, just this morning, a relationship, an opposite relationship, in that there was a magnitude 2.8 earthquake just almost instantaneously with the explosion that happened at 8:30, and it probably prompted a large rock fall down into the lava lake that produced that ash cloud this morning. Yes, sir?
Can you address gases coming out of this, let alone ash fall, which is just kind of an inconvenience? Are there dangerous gases that can come out and actually impact people?
Right. The question was again about gases that could be released during these kinds of explosions. There will be likely a sudden burst of an extra amount of sulfur dioxide, or potentially, but again, we don't think this would be any more than this area has already been subject to in the open lava lake period of the last 10 years.
So nothing.
There's no other gas phase that we're worried about right now.
Okay, thank you very much.
Yes, sir.
Is there anything going on in Mauna Loa?
Is there anything? Is there anything going on in Mauna Loa? The short answer is no, nothing that we're worried about. When things started to ramp up, it seems like last year, but it was just a few days ago, I think. We had a staff meeting, and collectively we committed to not forgetting about Mauna Loa. So we are watching the data coming in from Mauna Loa still. And I'll put Asta on the spot on the side because she's one of the experts on watching Mauna Loa, and you will confirm that the volcano is at this point quiet, right, Mom? Right, Asta?
This was about an hour ago.
So we're still watching Mauna Loa, yes. Yes, sir.
So one of the things that I'm getting hanged about on Facebook here is, do you expect there to be any sort of evacuations from this event? There's a lot of concern based on how the evacuation with Leilani went, that people may not be prepared and, well, things may not go well.
We are in contact with Civil Defense, who of course is the question was about evacuations. Are we aware of any evacuation planning, or will evacuations occur? We've been talking to Civil Defense about the unfolding situation here at the summit. They obviously have their hands full with what's going on in Lower Puna. But at the time that becomes even an issue, it would be their call. But the kinds of events that we're describing tonight, what Don walked you through, in my estimation, would not require any kind of evacuation from the volcano village. I think it's prudent, however, to say, as we did in our public statement this morning, that went out about 30 minutes before the big explosion, that all of the residents in the Kilauea Summit area think about your homes and businesses' exposure to volcanic ashfall. What vulnerabilities can you address now in terms of covering things, protecting things, having extra air filters on hand, the kinds of things recommended at this website, and also thinking broadly about your home emergency plan. And that's good for an increasingly severe volcanic event, if we should get there, but also for a bad earthquake or other emergency. So it's always a good idea for everyone to review your own emergency planning. Yes, sir, in the back.
What's the likelihood of the lava lake arresting quickly on the descent if it hits the lip of whatever it's feeding? Is there a possibility that will occur?
Kyle.
Could you repeat that?
Yeah. So the question is there a possibility that the lava lake will stop dropping when it reaches that liquid interface? Is there some interaction there? No, we don't believe so. As far as we know, the magma surface is really relatively indifferent as it drops in the conduit to the magma surface. So as far as we know, unfortunately not.
What about the conduit that it's flowing into? If it reaches that conduit level, can it arrest?
So the question was, what if it reaches the conduit that feeds out to the eruption site? Is that correct? Yeah, will it arrest at that point? And again, no. So as we understand it, magma rises up beneath the summit of Kilauea. That's the supply. It goes through the summit reservoir system, and then it drains out to the rift zone towards the eruption site. at this point, that lava lake is really nowhere, the lava lake surface is nowhere near getting down to the point where that conduit reaches out to the rift zone. Below the lava lake is the reservoir itself, and the shallow reservoir is probably over 1 kilometer deep at Kilauea. So there's no expectation that at any point the eruption will stop feeding magma to the rift zone. As far as we know, and this is difficult to constrain right now because the summit is deflating so rapidly, but magma is still supplying the eruption of Kilauea. It's just coming in much more slowly than it's going out. Up in front?
Yeah, I understand there's lava tubes that run through up here, and what's the likelihood of a fissure opening up here? Or fissure, how's it pronounced, by the way?
The question is that there's a big lava tube up here, and is there any possibility that a fissure would form along the lava tube? Was that the question? Yeah. I think the lava tube that you're talking about is the one that starts at Thurston Lava Tube and goes all the way down into Paradise Park. That is a lava tube that formed in the 1400s during the eruption of a big during a big eruption in that area. It doesn't have any relationship to any fissure at all, and so I think it would be simply happenstance and very unlikely at that a fissure would follow along that trend. Yeah.
In 1924, after the 2.5 weeks of ash explosions, then what happened?
After the 1924 explosion ended, then what happened? Kilauea kind of went into the doldrums, in a sense. The explosions ended in late May. A little puddle of lava reappeared in July, I think it was. And then after that, there were 6 or 7 other episodes of activity in Halemaumau spread over the next decade or more. So it was really a terrific downturn in activity from what had been going on at Halemaumau before that time, which was essentially continuous activity. We don't really understand why that happened. We think that the draining process of Halemaumau in 1924 was a comparatively shallow feature, the upper kilometer or two. Whereas the summit magma reservoir should have been replenished from a depth of 100 kilometers, 60 miles, and either that replenishment system turned off or greatly dropped down, or the magma was going somewhere else in the volcano, and we don't have an answer to that question. So I would have, because we don't understand that, I would have no idea as to what might happen currently if we do get into an explosive period and it then ends. I wouldn't know what to expect.
It might also be worth pointing out that the conditions elsewhere on the volcano are quite different now from in 1924. We're just seeing potentially the end of 35 years of activity at Pu'u'o on the Middle East Rift and the beginning of a new eruption in the Lower East Rift. Yes? Is Pu'u'o Pau? Well, time will tell. It certainly collapsed in a very large way on April 30th. And as of the last time we were in the vicinity, there's no active lava visible down in the bottom of that very deep collapse crater. The 61 G flow that was being fed from the Pu'u'o is most certainly Pau. Time will tell if lava returns there. We do know that there's material transporting in the rift zone past Pu'u'o and down to the Lower East Rift Zone, so that may be the new preferred outlet. Yes. Yes, in the back.
Thank you guys for coming and devoting so much of your time and everything to helping us out and communicating. You mentioned as historical scientists, you guys working with analogies, and Dr. Swanson mentioned with the analogy between the 24 situation and the current one. Is there any analogy to be made between the Isla-Au sequence of flows in the 14th century that preceded the 1790 event and the last 30 years of Kilauea flows that we're at now?
I think that's a Don Swanson question.
The question is really a good one. The question is whether there is an analogy between the Isla-Au eruption, which was the largest lava flow producing eruption at Kilauea since people have been on the island, took place during the 14th century, during the 1400s, and immediately preceded the caldera collapse. Is there any analogy between that eruption and the long-lasting Pu'u'o'o eruption? In other words, the implication could be that the Pu'u'o'o eruption is almost as big as Isla-Au. Maybe its ending will foresee the collapse of the caldera once again. That's a question that I've asked myself many times, and I think we should point it out to people, and because this makes us aware of the possibility that a caldera collapse is in the future. But there is one big difference, and I think that might be critical. And that big difference is that Pu'u'o'o is located way down the East Rift Zone. And the magma conduit pathway to it is very different from the magma conduit to the Isla-Au eruption, which was centered above Thurston Lava Tube. And I rather suspect that somehow that is an important element that would argue against the Pu'u'o'o eruption being a forerunner for a caldera collapse. But I'm uncertain about that, and I have, as I said, thought about this many times.
Putting the back here.
Should we expect the park to close again soon, like maybe Friday or Saturday?
Where's Tina running?
I can talk about right now. I was going to save it till the end. All right. Aloha, everybody. Aloha. I'm Jessica Farrakane. I represent the Hawaii Volcanoes National Park. And yes, we will be closing on Friday, based on all the information that you have had now. So you probably know that our new partial opening hours are 7 a.m. to 10 p.m. So as of 10 p.m. tomorrow, we will be closed until further notice. The end.
See, I guess I'll step in for Tina. There's a question there.
Yeah, just to follow up to what Kyle Anderson talked about, that there had been an evacuation of the magma reservoir mid-rift. I assume you were talking about at Maka'opuhi. How does that evacuation of that magma reservoir play into this whole analysis of what's happening at the summit and at the coast?
Yeah, so the question is, earlier I brought up the idea that magma had evacuated from the Middle East Rift Zone from, for example, the Maka'opuhi area, and how does that play into what's happening at the summit right now and down in Puna? It's actually a really great question, and it's one we're still actually trying to understand. These are really big changes to Kilauea that have happened in the last week. What's been observed is, of course, the collapse of Pu'u'o'o, and we have evidence from geodesy that magma has left the Middle East Rift Zone. That's feeding, we believe, a dike in the Lower East Rift Zone, which is reaching the surface and causing the eruptions. That part is maybe a little more clear, at least in places. What's really not clear right now is how the summit is connected to that. Normally, as I said, magma rises beneath the summit, then makes its way down the rift zone to Pu'u'o'o and erupts. It's been relatively straightforward for some time. We've had this large 6.9 earthquake, and one of the theories that we have is that these large earthquakes can actually open space in the rift zone. So during the event, the south flank of Kilauea moves a bit towards the ocean, and that can open up some space for magma storage. So it may be that what's happening right now is the magma from the summit is really going mostly into rift storage as opposed to directly feeding the eruption in the lower East Rift. But I will say we really don't know right now.
We've got time for one more question.
Okay, one more question. Anyone in the back? No? Right here.
If the park is going to be closed Friday at 10, what about the people staying in the park housing along the caldera? Are they going to be moved out?
We are working on our operations plan right now for that. The question was, if the park is closing on Friday, what about the people who are staying in the park right now at places like Volcano House and Kilauea Military Camp? And we are working with our partners right now on that plan. So I don't have a definitive answer for you, but those guests will eventually leave the park. And I did neglect to mention that not the entire park will be closed as of Friday. The Kahuku unit will remain open during its normal operating hours, which are Friday through Sunday from 9 a.m. to 3 p.m.
But it's the following Friday that you would expect the groundwater connection, right? Not this Friday. This Friday. Could you clarify that?
The intersection of the projected descent and that groundwater horizon, the exact point would be this Friday. But again, remember that that was a forecast based on a few data points. There's a lot of uncertainty about the exact elevation of the water table, so it doesn't mean that necessarily on Friday something's going to happen. Okay, I'm afraid that's all the time we have for questions, but I just want to, thank you. I understand that there's a lot of need for information, and I encourage you to check in with the HVO website. We'll try to be posting at least one update every day about the status of things, and we are in close contact with both the Park Service and Hawaii County Civil Defense, so that if there are additional messages that need to go out to the public, you'll find them through Park Service, HVO, and Civil Defense channels. Really encourage you to check out this website, and we'll try to get more of this information easily accessible through our website. And remember, what we're talking about now is primarily concern about ash fall, which is not a life-threatening process. It's a nuisance, and it can interfere with different parts of our life, but it is a manageable process, a manageable phenomenon. So thank you very much. Thanks, everybody. Thanks again to the park for hosting this.